Hello, dear students. This video is to demonstrate how the views of an object can be created in the first quadrant, in the third quadrant, using the tools of AutoCAD, using the tools of Inventor. Well, since the orthographic projection chapter uh, is not the studied yet in detail, this video is just to make an introduction how the views can be created, not to teach the details on the projection, the views, but just to answer what is the thing to do for having the views as first quadrant views or third quadrant views. Okay, later you're going to learn the details on orthographic projection and view creation. Okay, now first remind you saying first quadrant, third quadrant, we mean what? You know, in engineering drawing, it is the thing to visualize in the mind. What we have picture planes. Okay, these are 1, 2, 3 picture planes. These are primary uh, principal picture planes. These are the planes dividing the universe into 8 quadrants. This is called first quadrant, and this space is the third quadrant. Yes. In engineering drawing, either we consider the object as located in the first or in the third. What is the measure? In which case we select which quadrant? The main measure is the unit system. If at the place in the country SI unit system is used, then ISO says that the first quadrant is selected. ANSI says that where, say, in the countries where British or traditional American unit system is dominantly used, standard American standards says that the association says that American National Institute for Standardization association says that the quadrant to select is the third. After selecting the quadrant, well, of course, we visualize the object as located in the space. Here, the cyan colored one is the object. Actually, it is in the virtual environment, the model of the object, solid model of the object. Imagine the object located here or there. And then accordingly have the views as first quadrant views or third quadrant views. Okay. As I said, I'm going to educate you on the details on the views, orthographic projections later. But here, this video record is just to answer the question, what is the thing to do at the beginning for having the views indent as created in the first quadrant or as third quadrant creation. I'm going to answer the question first in AutoCAD environment. Yes, in AutoCAD I have such a solid model. For this model, I'm going to create the views. In doing this, well, define this side of the body as it is frontal side. Okay, and this is going to be top side, and in this direction object is to be observed to output the left side views. Okay. Accordingly, I'm going to create the views. In AutoCAD, similar to Inventor, if there is a solid model at the background, okay, the drawing is just a creation, not drawing line by line, but view creation. To be able to create the views, it is a must to have a paper simulation. In AutoCAD, for having a paper simulation, we clicked on Layout button. Okay. layout. After this click, then AutoCAD using its default configuration brings such a white paper. It is in A4 size. For this model, for this object, I'm going to use A3 size paper. Okay. If the outputting device is a printer, A3 is the maximum paper size. Assume that I have a printer, not a plotter, and the size of paper cannot be greater than A3. Okay, how can I teach to the software that paper size is A3? Bring the cursor onto layout button one more time, right click the mouse, and from the list it will appear, select page setup manager option. It is not for the first time, just I'm trying to call your memory. Already studied on such things, but here my purpose is just to make a review how the paper is set up, and then how the views can be created, first quadrant views and then third quadrant views. Couldn't answer the question what is the thing to do for enabling the software to create the views as third quadrant views. I'm going to answer this question after finishing the review. Okay, clicked on page setup option, and then in the setup managing dialog box, clicked on modify button, and then in this dialog drop this list and then select the printer. The output is to gather from where. Okay, if there is no physically connected printer, then you can use PDF writer, Adobe PDF writer, okay, and have the printout in PDF format. I'm going to select this printer option, and then paper size, drop the list. You see A4 is the automatically selected paper size. It is in the default configuration of the software. From this list, drop the list and select A3 option. Okay. Here plot scale is 1:1. This means whatever the size of the projection it has been created previously is, then the plotting scale will be the same. Okay. And then clicked on OK button. And then close this dialog box. Now the white paper is in A3 size. Okay, and then view creation. In the default configuration of the software, if you selected ISO template from where this stage, clicked on this and select the template option. If ISO template has been selected, then AutoCAD will know that first quadrant has been selected. You're going to create the views in the first quadrant. So AutoCAD automatically selects first quadrant option. See that it is true. How? Layout, right click the mouse and select from this list drafting standard setup option. Well, the meaning of this symbol, it is to say first quadrant. Yes, the first quadrant projection type option has been selected. So thanks to this selection, AutoCAD can create the views as first quadrant views. If the views are to be created as third quadrant, then this option must be selected. First see first quadrant projection. Have the views as first quadrant projections. Okay. And then to be able to start the view creation process, this command is written, view base. While writing the first few letters of this keyword, can find such a list. From the list, select view base option with a click. And then if you have the model still active in your session, then select model space option. But if there is no model active in the environment, the solid model of the object is in the memory, then select file option. If you select file option, then a dialog box appears and program will ask you to show the address of the model. Here I'm going to create the views for the one it is still active in model environment. So select model space option. And then yes, check whether the simulated view right now is just the front side view. If not, then click on down direction key of keyboard and select orientation option and then change the orientation. Teach to the software that not this side but the other side is the front side. Okay, how? Clicked on this option and then select the other side. But here in the simulation, that is the correct side. In my consideration as well, this is the front side of the body. Okay, and then, well, scale factor. Click on downward direction key and select scale option and then write a suitable scale factor. Well, for this model, I know tested it. The most suitable scale factor is 1 to 10, means 0.1 is the scaling factor. Okay, press enter. Okay, and then locate the view. If it is first quadrant projection, you should know that front view is created over the paper, or it is shown on the paper, not any other place but there. Okay, if there will be three views as front, top, left, then front view is created using such a part of drawing paper. So move the cursor to that location together with the simulation, of course, and then with a click anchor it over there. Say that it is the place for the front view, and then finish the base view creation stage clicking on exit option. And then for the other side views, move the cursor in the down direction and with a click locate the top side view. Move the cursor in this direction with a click locate the left side view. And then right click the mouse, click on enter option. That is it. These are first quadrant projections, you know. And then symmetry axis. You know, if over a projection there is a full circle or semicircle or full ellipse or semi-ellipse, then horizontal vertical symmetry axes are needed to show. If there is a revolved feature or the object is a revolved object entirely, then on the lateral side view of the revolved feature or revolved body, longitudinal axis is a must to show. Okay. To be able to show the symmetry axis, for horizontal vertical axis, we use the two-dimensional tool of AutoCAD. So I'm going to make a switching. I brought the cursor to the status bar and found the switching facility. Clicked on listing arrow and select mechanical option. It is to change the mode from 3D to two-dimensional mode. Okay, and then clicked on layout tab to see the created views again. And then for the symmetry axis, we use in two-dimensional environment this tool in drawing panel, symmetry axis creation tool. For horizontal vertical axis, creating horizontal vertical axis, use this facility. For creating longitudinal axis, use that facility. But this facility is applicable for having longitudinal axis if the views have been drafted once, not created. But center cross option is applicable. If this facility going to be used for the first time, the corresponding transparent paper, yes, in AutoCAD in its structure we use transparent papers. Some of the transparent papers have already been created, defined. Okay, these are called system layers. The layers created by the programmers of the software. These are the layers just used by the software automatically for as the address of some of the entities whenever these are output automatically called system layers. For instance, for axis of symmetries, this is the facility. Whenever this facility is used for the first time, the corresponding system layer is activated. Yes, now at present, you see here in the list, these are the available transparent papers. Okay, using this and that, this layers software created the views. In visible layer, AutoCAD created the projections of visible entities. In hidden layer, the images of hidden entities. These dashed lines, just the corresponding views of hidden entity. Okay, relative to observer. Well, I'm going to have one more layer. Just I drop this list and selecting center line cross option. And then bring the cursor to the vicinity of the circle, okay, for which horizontal vertical symmetry axes are needed. Of course, thanks to snap facility, you see this is 2D snap facility, and using this facility I already enabled the software to indicate center points and also midpoints. Okay, so I brought the cursor to the vicinity of circle. Its center is being highlighted. Indicate this point with a click, and then move the cursor to the vicinity of the midpoint here, 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 or there of the circle, and then indicate it to say that symmetry axis extends to midpoints. After the click, you see in cyan color we have the axis of symmetries, the format of symmetry axis. Later I'm going to deeply talk about the types of lines. The next chapter is about the types of lines. In language analogy, the alphabet of the engineering drawing. You're going to learn all the things about symmetry axis in detail. But here shortly say that symmetry axis is a thin line. It uses long and short dashes. Well, after using that facility and via which having the symmetry axis for this projection on this view for this circle, then drop the list of the names of the transparent papers. In the jargon we say layer, and this is the new one, AM7. Okay, in AM7 layer, I am sure AutoCAD creates and keeps the axis of symmetries. Okay, similarly for the circle on the top view, this circle corresponds to the top view of this cylindrical extension. Yes, while we're observing the object in this direction, you see this cylinder appears as a circle, okay, on its projection. Here it is. Symmetry axis, drop this list, center line cross, and then indicate the center, indicate the midpoint, and have the symmetry axis. Okay, to be able to highlight that this rectangle on this view, this rectangle on that view are the images of cylindrical extension, which is a revolved feature in general, we use longitudinal axis, show longitudinal axis. But since the views are not the drafted but created ones, for creating the longitudinal axis, well, this command is to be written. Center line. Okay, select from the list center line option, and then it is to say that a longitudinal axis. But sorry, before indicating the limiting lines of the projection on the projection of revolved feature, let me press escape button and cancel this symmetry axis invoking process because I forgot to select the axis layer. To be able to have the longitudinal axis in the same layer as created in the same layer, from this list select AM7 option. AM7 is the name of the layer in which AutoCAD keeps the symmetry axis. Okay, after with a click, making a click on the name of the layer, can say that I selected that page. On this page, in this transparent layer, transparent paper in the layer, going to have the longitudinal axis. And then write the command center line. Okay, and then indicate the limiting lines. This is one of the limit of the revolve feature, and this is the other limit of its surface. And after indicating the limiting lines, have the longitudinal axis between them. Do the same thing for the left side view. The left side view, this is the lateral side view. This rectangle is the lateral side view of the cylindrical extension. This hidden rectangle is the lateral side view of the hole. Okay, both of them, for both of them, longitudinal axis ought to be shown. Okay, in AutoCAD, unfortunately, the same command is to be written, or the same process option is to be clicked on again for each of the demanded ones. So write the command again, center line command, select center line option, and then indicate the longitudinal, for having the longitudinal axis, indicate the surface limit lines, this and that. Yes, between them have the axis. Rewrite the command center line. Okay, and then indicate the hidden line, this and that, for having the axis on the lateral side view of the hole. On the top side view, yes, this hidden rectangle corresponds to the image of the hole. Where is the hole? In the design of the object, you see there is a hole over there. Yes, for this hole, show the longitudinal axis on its lateral side views. Center line, write the command, and then indicate the limiting lines, this and that. Yes. If the length of the dashes is not suitable, not so correct, to be able to change the length of the dashes for all, you know, LT scale is the command. LT scale, and then into this box write a number less than unity for decreasing the length of dashes, in case greater than unity for increasing the length of the dashes. Well, here LT scale command is written to change the length of all the dashed lines, symmetry axis, hidden lines. Okay, here on the views, the length of dashes for the images of hidden entities, dash lines, is quite good, correct. But for this symmetry axis, the order of length is not so good, because along the longitudinal axis, having only one or two dash lines is a poor practice. Well, to be able to draw the attention of the reader that the line is not a continuous line but axis of symmetry, have more dashes along its line of action. To be able to change the length order for a certain line, use this technique. Select the line with a click. Okay. Select the line. These are the lines for which the length scale going to be changed, and then right click the mouse. But this is important, while the gripping lines along the selected line still shining, be able to right click the mouse and then select properties option. After selecting properties option, for the selected line, property table will appear in the screen. You can see full info about the selected line. To it is x, y, z coordinates for the starting, ending points. It is length, it is inclination angle, and it is layer. Here into the line type scale box, write a factor to decrease the length of dashes via which, for having more dashes along the line of action, write a smaller number. I'm going to increase the number of dashes by 2 via decreasing the length by 2. 0.5 is the new scale factor. Press enter and then close this dialog box. Press escape button. You see now along the line of action of the symmetry axis, instead of having 2 long dashes, I have 4 long dashes. It is better. Okay. After reminding you on the thing how the length of dash lines is changed, then continue on the rest. You know, margin lines in AutoCAD cannot be automatically invoked, while manually be able to bring the margin lines and title block. If the software is AutoCAD mechanical, you can use this tool. It is available in 2D environment. Annotation tab and title border. Click on this button. And then in the dialog box, select the same paper size from the list, A3. This white paper is in A3 size. Scale factor, I created the views 1 to 10 scale using 1 to 10. So drop this list. For having the scale factor as automatically written at the title block, select the same scale factor 1 to 10 and then say OK. Okay, and then, well, just clicked on this close button. Thereafter, well, actually, I made a mistake. Press escape button. First, from this list, select not AM7 layer. If it is the active layer, then the margin lines will be in center line quality. Select AM0 layer. In AM0 layer, AutoCAD keeps and creates the margin lines. Okay, so select this layer and then, well, clicked on this invoking button, paper simulation invoking. Yeah, the things are the same. Select 1 to 10 as the already selected scale factor and then say OK. And in this dialog box, clicked on close button. And then here is the paper simulation. Locate the paper, corner of the paper simulation to the corner of this white paper. Okay, and then, well, this stage is just title block filling stage. Skip that filling stage. In my method, title block is to be filled after having the views, after having the paper simulation at the end. After finishing all the things about on the drawing, then, well, fill in the title block using the text typing facility of the software. So skip that stage, clicking on simply OK button. OK. And then press enter for finishing this stage. If the paper is not just fully matching to the paper, then you can drag it a little bit more. Okay, holding this gripping point. Okay, you can locate it. Ortho facility may prevent you from moving the simulation in any direction, so toggle it off, and then much more easily you can locate it. Snap tracking off. Snap enabling off. Make it off. Much more easily you can locate the corner of the simulation to the corner of the white paper. Okay. These are the things to do for having the views in the first quadrant. Okay, now I'm going to create the views in the third quadrant. Select this adding button, have one more layout, and for this layout, yes, select layout option, paper size, check whether paper setup manager modify option is A4, not A4, A3. So select A3 size, okay, and then say okay, and then close this dialog box. And then to be able to create the views as not first quadrant but third quadrant, bring the cursor onto layout button, right click and select drafting standard setup option. And in the dialog box, select third angle option and then say OK. And then yes, start the view creation process, view, base, and then model space. And then yes, this is the front view in the simulation. I know that in the third quadrant, front view is created using this pad of paper. With a click, locate it, and then say exit. If the orientation is wrong, select orientation option and change. If the scale is not so good, then select scale option and then change the scale factor. You know such things. If the orientation is correct, if the scale factor is suitable, then click on exit button. And then move the cursor in the up direction. AutoCAD now knows that the quadrant is the third, so ready to create the top view over there. Locate it with a click. Move the cursor in this direction with a click, locate the profile view. Third angle projection, next to the front over here, we have the right side view, not the left side view. AutoCAD knows that it is so. So ready to create the views accordingly. Right click the mouse and then say enter. Yes, this is the right side view. See the first quadrant projection. Yes, this is the left side view, but here next to the front we have the right side view, and this is the top side view. Okay, the rest is the same. Symmetry axis, okay, add the symmetry axis, you know how. Add the paper simulation, you know how. Okay. Yes, in AutoCAD, this is the thing to do for creating the views first quadrant or third quadrant views. How about Inventor? In Inventor, I'm going to open a solid model, and for that solid model, answer the question. Yes. This semester, as the classwork, one of the classworks, you know, we already created the model of such an object. Here is the model, and for this model I'm going to create the views, okay, as first quadrant, third quadrant. So in doing this, I'm going to consider this side as the front side of the body. Okay. To be able to create the views in Inventor, yes, click on New File Creation button and then select the quadrant. If you select English option, then Inventor can understand that you selected third quadrant. If you selected metric, Inventor can know that you selected first quadrant. So first see how the first quadrant views are created. Metric option, and then obey to the rules of ISO. Make this template selection on ISO template option. Okay, I selected ISO template and then clicked on create button. You know this from the previous video watching. Inventor will bring paper simulation, not primitively white page, but also, you know, the necessary margin lines and the title block. It is an A3 size. If the size is to be changed, you know how it is changed. Edit, browser, sheet icon, edit sheet, and then can change the size of paper. But for this example, A3 is quite good. And then, well, start the view creation process. Clicked on base view creation button. And then, well, if the solid model is the active one in the environment, then automatically Inventor can detect that it is the model and for which offers such a side view. If the model is inactive, not active in the environment, but it is in the memory, clicked on the search button and then show the address of the solid model in the dialog box. And then you can sure that the simulated one is one of the side view of the selected model. Okay, well, clicking on the corner of the orientation cube enable yourself to see the simulation three-dimensionally, and then much more easily you can see which side you selected as the front side of the object, and then see the parallel surface of the orientation cube. It is parallel to the front side, and make a click on that surface. Then Inventor can understand that you're going to create that side view first. Okay, the front side is now parallel to the surface of the paper. Scale factor 1 to 10 is the suitable scale factor in this example, let's say. And I know that this is the place for creating the front views. Well, try 1 to 5 is also suitable. Increase the size into this box, right? Not 1 to 10, but 1 to 5. We separate numerator and denominator, you know, with a column. And then check whether the first slide style button is on. It must be on for enabling software to create not only the images of visible, but also the images of hidden features. And then, yes, this is the front view, and move the cursor here with a click, show the place for the left side view, and move the cursor in this direction with a click, show the location for the top side view, and then say OK. That is it. These are the views. Well, show the symmetry axis in Inventor annotation tab, and along the annotation ribbon, this is the facility to create the horizontal vertical axis. This is the facility to create the longitudinal axis. Start this button, clicked on this button and start the axis creation process, and then indicate the outer circle or outmost circle on the projection. We have two concentric circles. This is the image of one of the entities. Since it is a full circle, symmetry axes are needed. With a click indicate. On the top view, yes, similarly, there are some circles. Select the outmost one for having the axis of symmetries for all. On the left side view, this is a full circle indicated and have the horizontal vertical axis. How about longitudinal axis? Clicked on this button, and then this is a cylinder, and to say that the image of the cylindrical revolve feature, longitudinal axis is used. Show the limiting lines, click, and between them have the longitudinal axis, long dash, short dash. Okay, Inventor most of the cases well generates a suitable length value for the dashes for the length of dash lines. Okay, Inventor is a new generation software. Do the same thing on the left side view. I know that this hidden rectangle corresponds to the image of a hidden revolved feature on its lateral side view. So between them longitudinal axis is needed. While this is also a revolved feature, that's the lateral side view of a revolved feature. Show the limiting lines and have the longitudinal axis. This is the image of the contour bore of a contour bore tool, and between the limiting lines we need to have axis of symmetry. Do the same thing on the top side view. Between the limiting lines of this contour sink tool, axis is needed. Between the limiting lines of this contour bore hole, axis is needed. Okay. Yes. How about the third angle projection? Well, for the same model, this model, I'm going to create the third angle projections. This is first quadrant, first angle projection. Third angle projection. Clicked on new file creation button and select the unit system option on English. Okay, English option. Well, this is not to have the dimensions in inch, but also to have the views as third quadrant views. Okay, and then after selecting English option, make the selection on ANSI template. Inventor format, IDW is the extension. Select this template option and then click on create button. Thanks to selecting this and that, Inventor can understand that quadrant is the third and you're going to obey to the rules of ANSI. Yes, this is the paper simulation. For this object, this size paper, this is the size of a standard paper in accordance with ANSI. Yes, in my lecture note, A series papers are all in accordance with ISO, in ISO definition, but here in accordance with American Association, the codes of the standard papers are A, B, C, D, and E. E is the largest basic size. Here, Inventor automatically selected D size paper. Okay. Change the size of paper if necessary. You know how, sheet icon, edit sheet. Not D, but let's say C. Okay. Or vice versa. And then start the view creation process. Okay, teach to the software which site is, where is the solid model, and then the side of the object. This is the frontal side. Scale factor may be 1 to 4. Pay attention to the format. 1, 2, not colon but slash. Yes, in ANSI format, a scale factor is denoted using a slash. Okay, this is the place for the front view. Okay, move the cursor in this direction, show the location it is going to be for the right side view. Okay, and move the cursor in the up direction with a click, show the place for the top side view. Now Inventor will achieve the rest. First style button is on, scale factor is correct, suitable, and then clicked on OK button. Yes, now created ones are third quadrant views. The rest, symmetry axis, show the symmetry axis, longitudinal axis, show this limiting lines, surface limit lines have the longitudinal axis, this and that, longitudinal axis. Okay, on this view, show this, show that axis, on that view, show this, show that axis. Okay, horizontal, vertical symmetry axis, clicked on this button and then show the circles on the views for having the necessary symmetry axis. Okay. Yes, I think I managed to answer the question in AutoCAD in Inventor, how the first angle, how the third angle views can be created in general. Of course, there are some other details, but later you're going to learn the complementary things. Thank you for your watching. Stay healthy.